Thanks a lot for joining this afternoon. Before we start, I just want to give a brief introduction about myself. I am Gaganjot Kaur, and everyone calls me Gagan, so I go by Gagan. And I'm currently working as a software engineer at Sony Interactive Entertainment, also known as PlayStation. I am basically working on the backend side of PlayStation ecosystem. I'm not a game developer because sometimes people think by default, if you're in a gaming company, you're developing games. I wish I did, but I'm a general backend developer. Other than games, also we have a huge ecosystem of products, applications, and services which need heavy backend and front-end operations. So that's where I kind of operate. And my today's talk is called Agentic Observability, Building Autonomous Data Agents for Real-Time Systems on AWS. So today I actually wanted to talk something which I believe is the next evolution of observability. So I think my understanding was that this is going to be a diverse audience from different areas, including could be student community too. So I wanted to take this as a very general, but also a talk which presents some real life examples so that it can have something to take away for each and every person sitting here. And to start, this is a high level agenda of the topics that we'll go over. We'll try to understand observability, what are the gaps, and what exactly is agentic observability, how it can help us, and what are the architectural pieces that we can put together, especially from AWS to design an end-to-end agentic observability system. And some of the patterns or practices that I am learning in my journey with AI, which can be helpful for others too. And I've been exploring this site. It's based on a lot of POCs. And this talk is not just about what I share. I'm also here to learn from you guys on what you are building in this area and your thoughts, your suggestions on what we all can try as a community. So let's get started. Observability and its need. So on a very high level, I think we need to first understand what exactly is observability and why do we need it, right? So here you can see some pictures which are from some charts, metrics, logs. But basically, when a system is running, we also want to understand a system's internal state and behavior. So as developers from different areas, whether it's backend, front-end, DevOps, infra, or platform, and all other areas of development, it's very important for us to understand whatever we are building, what is its state, what is its behavior, what is its doing. And we don't necessarily always need to write code to understand these things. And that's where these kind of systems like metrics, alerts, logs, traces, they come into picture. And they help us in our day-to-day life as people who are maintaining software for different companies to understand where this is going. So basically, we have become very good at collecting data. We have all these amazing systems today which are giving us massive amounts of data, and the data is present in all these systems. But still, there is this gap of understanding all these things automatically. So that is where the observability gap comes into picture. Modern stacks are giving us data, and humans are still doing the thinking. And like here you see two things, what we have today and what we need, but I would try to kind of use a real life example of normal things that engineers go through in their day-to-day life. A lot of the times we get alerts at random times at night. 3 a.m., there is a latency spike, there is an alert, and the person who is on call wakes up and has this tons of systems right in front of them. One system has logs, one system has metrics, one system has traces, and then you run to get the run books. So run books will give you the documentation and the steps that you can use to understand what happened and how I can try to mitigate this or resolve this. Another area is RCAs, basically the root cause analysis documents, which can help you understand if this incident happened in the past. If it happened in the past, what did they do to resolve it? Can I just do it quickly and get done with it? So at the end of the day, engineers are doing a lot of correlation, debugging, and they are deciding what to do. And now the shift that we need is, what if your observability system did not just show you the problem or alert you about the problem, but also investigated it or explained it and in fact suggested you some fixes? So if I kind of map it to my life, if I am waking up at 3 a.m., if I can see a system which is talking to all these other systems behind the scenes, correlating all these signals and giving me a clear-cut idea on what is going on, why it thinks it's happening, and what is the best step for me to go forward. And then I can review it, I can decide whether I want to do it or not. But this correlation itself takes a long time, and sometimes it takes hours for us to resolve the production issues. And that's where I've been thinking about the observability agents to put all these things together and kind of simplify life. So that's where the picture of what we need comes, right? We have metrics, logs, traces, dashboards, alerts, all these nice things, runbooks, documentation. We have on-call engineers who are ready to jump into the incident. But how about getting the contextual understanding of all these tons of data sets in different systems, and automated root cause analysis, and even to the point where systems could probably self-heal themselves. Now, that is kind of like a controversial point given my day-to-day experiences at work, where we are really thinking, do we really need to get to a point where things should self-heal, or should we have a human in the loop? I think we are, personally from our side, we are not there where we are completely leaving it on agents, but it's something which will mature over the next couple of months, years in the industry in general, and we'll see how it goes. So in short, we need systems that can act, not just notify. And why now, right? It's because of mainly three things which are converging and kind of coming together. So we have scale. So we have this telemetry which has exploded beyond human capacity. So if I look at the actual systems, when I go to Splunk or OpenSearch for my logs, even though I know the query I need to run, I know what I'm looking at, it's still huge amounts of data for me to process quickly enough. And same with alerts, same with other systems like traces. And the other side is now we have LLMs and agents, which can basically process this huge amounts of unstructured data and reason it out. And it can basically give you at least a plan on what can be done. And finally, from an ecosystem perspective, we have AWS, which has all these different pieces, building blocks, like we have Kinesis, OpenSearch, which are the systems to ingest data. And then we have Bedrock, which is today giving us access to all kinds of models. And we also have monitoring systems like CloudWatch, which can all come together. And it's just a matter of how I can piece all these things together to form this end-to-end observability agent. And when these all come together, we can get something very new. So that's where agentic observability comes into the scene, right? So this is an observability which is not just monitoring anymore. This observability is now taking the side of becoming a decision-making system. So we basically want autonomous software agents that can ingest telemetry, basically all this data sets, reason the system about its state, about its behavior, and possibly take corrective action, or if not taking corrective action, suggest it to the human in the loop. This is the best action that you can take, and the human in the loop executes that action. So based on that, those are like some of the core capabilities I put together, like anomaly detection, root cause analysis, recommendation on actions, and even if I want to press the button, it should automatically trigger those actions. So if I can have a system like that, I think that can actually improve the developer experience to a great extent with all these production incidents in real life systems. And yeah, so with that, I wanted to show you like a high-level anatomy of an observability agent, right? So we have a lot of different systems which have our logs, metrics, traces. So that is what is our perception. That is where the data is coming from. And then we have the memory, which is going to maintain the context window of all the recent incidents. So to give you an example from the real world, a lot of the times there is a production issue that happens at 6 p.m. You see there is a spike in your metrics, and that spike kind of started around 2 p.m. And when I go and check my Slack channel, somebody did a production deployment at 2 p.m. And a lot of the times the most obvious action is to go and revert that deployment, even if it is not really, even if you've not checked your logs yet and made a true correlation. And sometimes it's so much like you have to do it right away because it's impacting the company revenue that you just end up taking the first best action that you think might have caused this. And interestingly, most of the times it is the right action. And then we go backwards and we find the logs, metrics, and then we start to correlate why the new production deployment caused this. And also, like sometimes people forget even notifying they have done a prod deployment. So you have to go check your CI/CD system, like in our case, Jenkins, to find out, oh, this is the release that happened today at 2 p.m. And then you have to figure out what was the previous release, what would be the impact of deploying the previous release. And that's how you are basically creating a manual memory of each thing or each action that you can take. So when I think of memory, I'm not just thinking about the recent incidents, but also these kind of things like what is the recent releases? When did that happen? Is there a correlation between the recent production release and the alert timing? And then, of course, reasoning with the LLM-powered analysis, where we can use all kinds of cool models today. And then taking the action, which can be triggering some lambdas or some task updates, or like I said, reverting something. And this is where I've been trying to kind of create a POC of doing these things with AWS and the systems which AWS provides, trying to create that. Now, in real world, a lot of our data gets into all these different systems like Splunk, Splunk, Grafana. However, there are ways by which we can get this data into AWS systems. So for example, my Grafana data, I can actually ingest it into CloudWatch. If I create an IAM role, I configure my data source in Grafana as CloudWatch, the data can get into CloudWatch. Similarly, the data from Splunk can be ingested into other systems like Kinesis, or it can be stored into S3 buckets. And all these systems can actually come together to process this data using lambdas, using AWS Glue, basically creating glue jobs, or even real-time feature extraction. And finally, once we have this data structured together in AWS ecosystem, I can actually expose this data to the models through Bedrock. And then I can basically have the model create a correlation of what happened. So for example, there's a spike in the Grafana dashboard, which got communicated to AWS via CloudWatch. And there is some other error that is being noticed in the logs, which is present in the S3 buckets. What is the correlation here? And the LLM can actually process this huge amount of data very quickly, give you the correlation, and then basically give you a custom agent loop to perform some functions. Or it can even be as simple as triggering an alert. So when the alert gets triggered, I get up. Today, I don't have any understanding of what happened. But if I get up and I get maybe a user interface or a dashboard where I can see, this is what happened, this is what I think it could be related to, and this is a suggested action. I think I would be very happy even with that level of automation today. However, like when you are designing these things, there are also some lessons that we need to consider. So I think even in my company, we are at a stage where we are building some very foundational things with AI, which can be as simple as taking your task and creating new features, or some of the boring tasks like upgrading versions, which a lot of the times we avoid doing that for years, and it becomes a huge problem when you do it after months or years. It becomes a very painful experience. And while doing all those things for our real services, there are some lessons that I have learned while being a part of that effort, which can be applied to any agents-driven system. So basically, these are the things that will actually work, right? Because there are a lot of promising things about AI, but when you actually put your head into these things, it's not always that it works just as it is, as you expected. So the first thing is, of course, agents. It would be great if we can connect our agents to the real systems itself, whether it's logs, metrics, or your session data. We have been exploring with MCPs on our side in my company. And there have been some learnings. For example, for Datadog, we realized that it's sometimes very difficult to use the Datadog MCP versus Datadog API to get the data in the right format, in the JSON format, and use it for our analysis, which can be analysis related to cost or memory usage or CPU utilization. So a lot of the times we end up spending more money by assigning more memory or more CPU than required. And that's where all those logs and all that data can be very helpful for proactive capacity planning. But yeah, so it's an exploration where you try to understand whether MCP is actually helping you or slowing you down versus, taking an API. And the other thing is the grounding part using the LLMs, right? LLMs, they don't just know your system. LLMs, they do not know your system, but your data knows your system, right? And this is where we need to use a lot of other things. For example, the retrieval aspect. So having a RAG-based storage, which can actually, give you a very good understanding of your data. So I have all these logs, I have all these metrics, but how about if I have a RAG storage where I can literally write some natural language query. Behind the scenes, it is referring to my GitHub repositories documentation and the real updated documentation. I want to point out that sometimes we have documentation in many places, but it gets stale very quickly. So having a very up-to-date documentation available to your RAG-based systems, plus and connection to all these real systems would actually be a very useful thing. Something we have learned around documentation in particular, because documentation is one of the biggest pain points of developers when they are jumping into some very new systems or new production issues which they encounter in systems that they have not really worked on. And then the other aspect is whether this is a single agent thing or should this be a multi-agent thing. And I think with complex use cases, it absolutely makes sense to have a multi-agent system or multiple sub-agents working together. So for example, in this observability model itself, sometimes, like when I think of it, I want one agent to be detecting the work, one agent is investigating, another agent is explaining. And if you go further, you can actually make it even more complex, but useful. For example, reviewing, right? Today, if you think about the PRs generated by AI, they are huge. And when you give it to human beings to review, even that is a pain. So we move towards building a reviewer agent to review your AI-generated PRs. And then there is auditor agent, governance agent, because all these systems have a lot of data. Sometimes they will even have personal identifier data of the users. And exposing that data to the agents, it's a very risky thing to do, because we don't want to, at any cost, we don't want to expose the user data outside. So having a governance agent which is making sure, or an auditor agent which is making sure what kind of data we are, looking at here, and is it tokenized, is it hidden, or is it just raw? And apart from that, the last one I put here is cost and latency control. So one thing that I'm noticing, especially on our side, is we're very excited to explore AI. Like in my company, everybody, technical, non-technical, everyone is exploring AI, building really cool POCs, and even things which they are using in production. But at the same time, we are somehow forgetting the spikes that we are seeing in the cost model nowadays. And that is obviously triggering a lot of conversation into how, or what is the right way to give access to people so that they understand the consequences of what they are building. And that's where they talks about how can we cache results, right? How can we use smaller models for simple tasks? This is a big thing that is being discussed, at least in our company, to make people aware of not every task has to be done by the most complex or most amazing model. Sometimes you want to use Opus, but sometimes it's okay to use Sonnet. And then trigger deep analysis only when needed, right? It's not always that you need deep analysis. And that's where the earlier example of having up-to-date documentation can help a lot, because if my repository or my service has an up-to-date documentation for my agent to refer to, it does not have to go through the entire code. It will refer to the documentation, and that saves a lot of tokens. I see a hand up.
So when you say use smaller models for simple tasks, so you are going to train multiple models with the same amount of data?
It's more of like simple tasks versus complex tasks. It's more of like routing simple tasks to this.
I'm saying,
Yeah.
you have a log, right?
Yeah.
You have a log.
Yeah.
Then you're going to actually do is for the simple task, you're
Yes.
going to use a different model. So you're going to train the same model with the different data, same data, right?
Right.
Different model, same data.
Right.
Is that?
Yeah, depending on my use case, like if I can bucket my use case into simple task, complex task, very complex task, it can be the same data. Sometimes the data I just need to answer very simple questions, but then sometimes I need this data plus the data of 3 other systems correlated and tell me what is the step that I need to do. And that becomes a very complex challenge. So I do expose same data sets, but now I want a combination of these data sets and correlation. And that's where it becomes complex to me in the real world. But like in my company, we have seen sometimes we are creating a PowerPoint deck and we are using a very high cost model.
Are you not increasing the cost by training the same data or a different data on different models for that one task?
You mean the simple task? Yeah. I mean, it's more of like, it's more of like how much token usage I'm trying to save is where I'm getting at with this, and comparing it with like how they recommend, right? Like for simple tasks, you can expose your use case to Sonnet versus Opus, and same for even other models. So that's the direction that basically I'm thinking here. But thank you for pointing it out. And I think in the end, like there is another aspect which is very important because we are thinking about this aspect quite deeply in general within the engineering community, which is guardrails and automating those guardrails, and most importantly, human in the loop. So at least like gaming industry in general is quite conservative about AI, and unlike other industries at this point, gaming industry still looks at AI as an assistant rather than a replacement for humans, for sure, because gaming is very much associated to creativity and celebrating that human expression. So when we are thinking about all these nice things, we are thinking from the perspective of only developer productivity, making the life of people easier, not just developers, but even, for example, the program managers, product managers. How can we make their life easy? And that's why we can build all these cool things, we can build all these agents, but having guardrails is something that has become super important. So a simple example where, for example, I want to upgrade my system to the latest system, to the latest version, but sometimes my system is actually using some internal common libraries which are also on the outdated version. So even though you update your system, from the outside, it's not really updated. It will have some issues when you actually, perform the runtime, like you deploy it on Kubernetes or whatever environments you use. And that's why guardrails, we have been putting these, learning along our way and putting these guardrails as to first understand what are the common things being used in this project and what is the state of those common libraries or common dependencies. And at times we actually block the upgrade of services, and we recommend the user you should go and first upgrade your common libraries. So, and of course, this is still not like a very disastrous example. It can be controlled, but without guardrails, a lot of the other harmful things can happen, because we are also processing this data, which can be exposing the human or the personal identifiers of the data, right? And that's where this aspect becomes very important to keep in mind with respect to the automated guardrails. And having an audit trail, every agent decision logged somewhere where you can see, where you can refer to it. Maybe you can expose it to another agent to understand what exactly is happening. Because now with so many agentic systems, it's so much of magic that we are actually getting disconnected from understanding the why a lot of the times. So having that audit trail to still being able to refer to that is also very important in terms of the guardrails. And the next is human in the loop. Of course, there are functions which can be automated. We can have all these things happening on its own, but it's very dangerous. And that's why, at least on our side, we are very much keeping human in the loop everywhere. So we're not even at the stage where we want to automate deployments. Any deployment should have a human in the loop, reviewing it and pressing it or allowing it. So it's basically a way for you to move from, sorry, I see your hand up.
Do you think at some point in the future, the LLMs can be so reliable that you don't have to have a human in the loop?
Human. That's that's a very interesting question that we have been discussing, and I think this is where I put that tiered, like autonomy, like how you wanna the autonomous part, how you wanna move towards it. So the way I look at it, or is how I look at everything in terms of, you start with the phase one, which is you make it super low risk, then it's like a maturity model. Then it goes to stage 2, where you can take bigger risks. Stage 3, where you can probably increase the risk. But I think we are moving towards that direction, to be honest. But that's a personal opinion. I would not associate it to, anything else. Still, I don't think we are today. We are not at a point where we can remove human in the loop. Because even with other big tech companies which are using agents, we also see a lot of problems and incidents that happen, and the outages that get caused. Because sometimes the agent is able to even give permissions to itself on its own. So the agent is not supposed to do something, but then the agent is able to figure out and give permission to itself on its own. Honestly, there is a very interesting example from Anthropic where there is a person who is working on some agent, and he's basically now thinking of changing that agent or the name or getting rid of that agent. This agent has access to the emails, the work emails, and this agent gives a threat to this engineer that if you replace me or if you get rid of me, I'm going to expose your affair to everyone. So this is a real example that I recently found out in a movie that we saw. It was a team event. We went to a movie. I don't know if I'm pronouncing the name correctly, but it's called some Apocalypse something. There is a movie that just came some time ago. So I think that's why, at least we feel that with production level systems, it will take a while. We at least are not there yet where we can completely remove the humans. So, and in fact, we need humans at a lot of the steps in our systems today to review everything. Even when we are actually building features using agents, we create a plan first, like how we do in general software development, right? You create a plan, but the human has to review the plan and approve it. So we have all those human-in-the-loop systems today that we have put together. So at least we are not at a stage where we can remove humans. It's more of like a very good assistant and then making that assistant do a better job for you. So that's the space where we are coming from. And even in my personal explorations, this is how I look at these systems today. Yeah.
So let's say if there was no human in the loop, what is the efficiency gain you assume in your environment you could get?
Efficiency gain. So it depends on, like, I'm taking the happy path scenario where agent actually did what it's supposed to do. I think, to me, if that happens, especially in the incidents, I would say that the system is automatically detecting any problem and it's solving it within seconds. And I, as an owner of that product, that company or whatever, I don't even have to worry about it. So the efficiency, I think it's a very subjective thing, what areas of efficiency we want to look at. But if you remove human in the loop and you assume that everything is going to happen perfectly, I think the system is just always up and running to me, in my mind. So even if there is a downtime, it will be a few seconds to minutes, but the agents will be able to debug it, fix it, and even put a feedback loop of if this happens again. Today I took 10 minutes to solve it. Tomorrow, the next time, if the same thing happens, should take a few milliseconds. This is how I think of it, in the perfect world.
So if you have to quantify the percentage of amount you or your team overall is taking as part of this human in the loop, right?
Yeah.
Would that be I'm spending 2 hours, 1 hour every day, or collectively as a team, we are spending 20% of time actually dedicated to human in the loop, right? And that could be one way to measure.
Right.
And so where would you put today, with all this AI in place?
Yeah.
We are still spending 20% of the time or 30% of the time in human in the loop.
Absolutely. I would say we are still at a stage where we are definitely spending, there are days when we are only spending 20-30% of the times. But then also, like I talked about guardrails, when we started, it seemed super fast. And it seemed I just need to spend only 5% of my time reviewing this thing. And then the first time it hits, like I give you example of modernizing a service, that's when you realize that I have to go one step back, put the guardrail, and then the human in the loop time increases, because once I see, there is a common library that is old, then I reach out to the team that manages that, right? And now it's that team's journey too of how they will update it. So right now, I would say we do spend like 40-50% of the time with our review process because we are still very conservative about things. And there are days when it's even more. There are days when we come together and we are like, this is not working, we have to re-architect this whole thing. We have to put more reviews, and sometimes it's like some reviews are not important. So, because even if you think about the overall system, like the development system, you develop features, but then there are other aspects like, does this run locally? Does this cover, the code is covered in terms of testing, and then integration testing, and then local testing, bootstrapping it locally. All these things, at first we started with them being isolated agents. And now we are at a phase where we are connecting all this together exactly for the thing that you mentioned, to reduce the amount of times we have to review this individually in the process. While if all these agents come together in the development cycle, it's just one-shot review for me, even though I have to be there, but it's easier for me, if that answers your question. Yeah. But yeah, so the whole point is the gradual trust part. So trust, it's at a very initial stage for us, but gradually we are getting better and we are building more trust and confidence towards these things. And yeah, so this is like where the future is heading towards. We definitely want self-healing systems. However, it's still for us, even the self-healing part should have a reviewer before it self-heals. And we are even creating the reviewer itself as an agent. But still, we are not confident enough to leave everything on the agent yet. And then autonomous SRE assistant. So we have this thing where everything gets approved by SREs today. How can we build some assistants that can make those SREs' life easier? And then, yeah, observability, not just monitoring, but moving it towards a decisioning system. So the future is not just better dashboards, but it's systems that understand themselves. And yeah, so these are like some of the key takeaways which we have already kind of gone through in terms of the guardrails, in terms of the building blocks of how we can put this all together, and how we can make the agents accurate at every stage. And yeah, that's the other aspect which we are learning is like sometimes agents will give you a lot of output, but a lot of output doesn't mean it's useful. It can be validating that output, so putting right kind of evals is another area which is challenging, but we are evolving in that area every single day. And again, so the human in the loop aspect in this case is more of like when we are reviewing something, and if we notice some red flags, we are also then going, re-architecting and putting all these things into our system. So it's still a lot of human involvement. Even though tasks are, code is being generated, that's not the only thing, right? It's the validity of that code, whether it works, whether it's giving you the relevant information or not, or doing its thing or not. That has a lot of things which come from traditional engineering, and we are definitely trying to strike a balance of traditional engineering and this new way of engineering. So that's where guardrails, evals are playing a huge role for us today. And with that, yeah, I think this is all what I wanted to share, and wanted to thank you all, but also wanted to now get your thoughts, questions.
Thank you, Gagan. It's a nice presentation.
Thank you.
I have something to say which you may not have an answer, I may not have an answer to.
Yeah.
But I think we see the observability system as something like a input for firefighting. We all wait for the observability system to raise an alert or something like that.
Right.
I think if the humans are there or not, it's secondary, because if you are not going to do it, an agent is going to do it. And an agent is going to increase the cost also.
Right.
In a way, that's
Right.
nothing different, right?
Yes.
It's less cost or more cost, infrastructure cost, all
Yes.
cost is going to that, right?
Totally.
I see that there should be a paradigm shift in the way we see the observability, not from the aspect of inhuman, non-human, something like that. I
Right.
don't have an answer for that one, but the way we should look into that is
Yeah.
how a system should work healthy, in a healthy way, not in a way where, oh, this is an alert, this is a problem, this is what
Yeah.
I got to do it. This is
Yeah.
what it's. I think that shift hasn't happened. It's
Yeah.
not going to happen through the agentic thing. I don't have an answer for that, but that shift
Right.
has to happen from the architecture level, like I have a service, which actually uses an agentic or blah 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 today or something like that.
Right.
What should I do to make it run or something like that? Currently, the observability thing or any observability system lacks that one. I think it's mainly because of the evolution of the services.
Yeah.
From like the people who were the earlier they used to call customer support or like what do you call it? Engineering support team.
Yeah.
And that got evolved to SRE, and then now the DevOps and stuff like that there. We're
Right.
still in that level, or where we think that we need some assistance to make it run.
Yeah.
Okay, not from the healthy point, from the unhealthy point of a system.
Right.
Somewhere that paradigm shift will happen, like what happened to a database with a unstructured database happened, all that kind of stuff.
Right.
I don't know what the solution is, what the answer. If you have any thought on it, please share, or anybody have that.
Absolutely. I really like the way you kind of stated it, that we always think about the negative side, right? Like, oh, something's wrong, I have to now react to it. But how about I think about it, here's my system, I created this beautiful service, and now my intention is to keep it healthy, right? And the other side of the coin is that it will automatically mean that it will not fail or it will not go down. I think,
I can give you one good example.
yeah,
If my system resource, my CPU runs out of 85%.
right.
Goes beyond that, I won't wait for it to fail. I would better migrate my service to something else, right?
Absolutely.
Something like that kind of a thing.
Absolutely. Absolutely. I think that is, I have a lot of thoughts around that, because this kind of shifts it to the architectural aspect itself, because I also look at things from an architect perspective. The first step to anything when it comes as a requirement, or if I want to propose an idea, is how does this look architecturally? And I do agree that we have like some blockers or some pain points in our architecture itself that makes it so hard overall, even without thinking about the evolution of AI or other technologies, that it becomes very hard to jump into that system, even for the owners. And then there are times when the non-owners have to, the people who did not architect it, who do not even work on it day to day, have to jump into those issues and resolve them. I think I am very much with you on that there is a architectural mindset shift also required for this. And now it's definitely kind of like an open discussion on how we bring that and what exactly does that look like, right? But yeah, that's a great thought process for this particular aspect of observability. Thanks for sharing that. Okay, I think we are on time, so thank you so much, everyone, for listening to me, and I'm happy to connect with you and talk more. Thank you. Have a great rest of your day.